Welcome to AI Frontiers, your guide to the latest advancements in artificial intelligence research. Today's episode is titled Vision Unveiled, the 2025 Computer Vision Breakthroughs, with the subtitle Synthesizing 149 Papers, published on 2025-05-27 to 2025-05-27. This episode presents a comprehensive snapshot of the cutting-edge in snapshotting insights from 149 recent research papers, each of which was published on a single day and indexed under the Computer Vision and Pattern Recognition category on the arXiv preprint server. The discussion will unpack core research themes, technical methods, and emerging trends, offering value to both newcomers and seasoned experts in the field. The goal is to illuminate the frontiers where artificial intelligence meets the visual world, bridging foundational knowledge with the latest scientific discoveries. Join as we journey through the dynamic landscape of AI vision, exploring not only what is happening, but why it matters and where the field is headed. In this deep dive, listeners will discover a guided journey through computer vision's most recent leaps. Key highlights include high-impact research themes and discoveries, with a focus on how generative models and efficiency are shaping the field. The discussion will cover the pursuit of robustness, the integration of multimodality, and applications in real-world settings. Technical methods powering these breakthroughs will be explained in accessible yet precise terms. Finally, the episode will explore what lies ahead for computer vision and artificial intelligence, outlining the challenges and opportunities that define the next wave of research and application. To ground the discussion, it is important to understand what computer vision is and its role in today's world. Computer vision, classified under cs.CV in the arXiv preprint server, encompasses the development of algorithms and systems that enable machines to interpret, analyze, and understand visual data, mirroring human perception. This field powers technologies ranging from self-driving cars and advanced medical imaging to robotics, industrial automation, and scientific research, such as climate monitoring and wildlife tracking. Computer vision extracts meaning from complex visual data, bridging the gap between artificial intelligence and human perception. As the volume and diversity of visual content continue to grow, computer vision remains essential for next-generation technology and insights, sitting at the intersection of artificial intelligence, data science, engineering, and the cognitive sciences. A core theme in recent research is the advancement of generative models, especially diffusion models for image and video synthesis. Diffusion models have become prominent due to their ability to produce highly realistic images and videos, as well as handle cross-modal tasks like text-to-image generation. The Alter framework, introduced by Xiaomeng Yang and colleagues, demonstrates a significant leap in efficiency, enabling diffusion models to generate high-quality images with a fraction of the computational cost required by previous methods. This innovation makes it possible to deploy generative AI in real-time creative and industrial applications, marking a shift from laboratory demonstrations to practical, scalable systems. Generative models are thus moving ever closer to powering real-world solutions, blending efficiency with realism. Another central theme is the pursuit of robustness, adaptation, and generalization in vision models. As computer vision systems are increasingly deployed outside controlled environments, their ability to perform reliably in diverse, unpredictable conditions becomes crucial. The FRAMES-VQA benchmark, led by Chengyu Wang and collaborators, rigorously tests model adaptation under data shifts, reviewing limitations and highlighting areas for improvement. In parallel, the MedBridge framework by Yiton Li and colleagues addresses the challenge of adapting vision language models to medical images, overcoming domain gaps, and the scarcity of annotated data. Together, these efforts emphasize the importance of building trustworthy, versatile AI vision systems, capable of robust performance across environments and domains. The integration of multimodal and multi-view reasoning represents a further frontier in computer vision research. Modern vision models now combine images with language, audio, tables, and other data types to achieve richer, more context-aware understanding. The MMT benchmark evaluates the ability of models to reason over complex mixed-modality data, while ViewSpatial Bench tests spatial reasoning across multiple viewpoints. These developments push the boundaries of comprehensive scene understanding, enabling AI systems to perceive and reason beyond the limitations of a single lens. Such advancements are essential for achieving deep, context-aware perception in robotics and embodied artificial intelligence. Research into segmentation, detection, and fine-grained visual understanding continues to expand the reach of computer vision. While these tasks have long been fundamental, recent advances emphasize scalability, robustness, and context awareness. Notable contributions include breakthroughs in few-shot segmentation, such as the SANSA framework, and the adaptation of scalable brain MRI segmentation methods for medical imaging. The YOLO SPCI model exemplifies advances in object detection for aerial imagery, employing custom attention mechanisms tailored to unique domain challenges. These innovations have improved accuracy not only in traditional benchmarks, but also in new, demanding environments such as remote sensing and specialized medical applications, broadening the impact of computer vision across diverse fields. Methodological progress in benchmarking and evaluation is fueling advancement across the field. Open-source benchmarks and new datasets have become pivotal in driving innovation and ensuring transparency. Resources like HDR-SDR-VQA provide standardized protocols for video quality assessment. Video Home supports complex video reasoning, and Dory evaluates orientation understanding in multimodal models. These benchmarks not only measure progress but also expose persistent gaps, guiding researchers toward unresolved challenges. The proliferation of robust evaluation protocols accelerates community-driven progress, ensuring that advances are both meaningful and broadly applicable. Several key discoveries are shaping the current trajectory of computer vision research. Notable breakthroughs include the development of fast, high-fidelity diffusion generation with the ALTER framework by Yang et al., robust generalization in visual question answering through the FRAMES-VQA benchmark by Huang et al., and self-supervised object learning from motion demonstrated by Liang et al. Efforts to reduce hallucination in vision language models, exemplified by Fazli et al., and efficient adaptation to specialized domains, as shown by Li et al., further highlight the field's breadth. Together, these discoveries represent significant strides in capability, reliability, and applicability, marking the maturation of AI vision research. The technical methodologies driving these advances are varied and powerful. Diffusion models, utilizing iterative denoising processes, have set new standards for generating realistic images and videos. Vision transformers, leveraging global attention mechanisms across image patches, deliver strong performance across tasks ranging from classification to segmentation. Multimodal fusion techniques merge visual and non-visual data, enabling richer reasoning and understanding. Self-supervised learning methods, such as contrastive learning and masked modeling, allow models to leverage vast amounts of unlabeled data. Rigorous benchmarking and the use of synthetic data underpin robust evaluation, ensuring that progress is both measurable and reproducible. Among the seminal papers in this collection, Object Concepts Emerge from Motion by Haoqian Liang and colleagues stands out for its innovative approach to learning object representations. This work demonstrates that unsupervised learning from motion boundaries in videos can successfully cluster motion cues for object discovery, employing contrastive learning to yield robust visual encodings. Remarkably, the resulting models outperform supervised baselines in three-dimensional detection and segmentation tasks. This paradigm, inspired by developmental neuroscience, points the way towards scalable, human-like learning for autonomous agents, utilizing dynamic cues from raw, unlabeled video data streams. The paper, ALTER, All-in-One, Layer Pruning and Temporal Expert Routing for Efficient Diffusion Generation by Xiaomeng Yang and collaborators, marks a significant advance in generative AI. This unified framework combines layer pruning and expert routing, managed by a dynamic hypernetwork that optimizes computation at each step of the diffusion process. ALTER achieves a 3.6-fold speedup over prior diffusion models, while maintaining the same level of visual fidelity. This efficiency enables real-time, on-device generative applications and sets a new standard for image synthesis. The methodology supports broader deployment of generative models without sacrificing output quality. Another influential contribution is MedBridge, Bridging Foundation Vision Language Models to Medical Image Diagnosis by Yitong Li and colleagues. MedBridge introduces focal sampling to extract high-resolution medical features, a query encoder to align pre-trained models with medical diagnostic tasks, and a mixture of experts mechanism to enhance diagnostic accuracy. The framework outperforms previous adaptation methods by up to 15% and operates efficiently with minimal retraining. By democratizing access to advanced AI tools in healthcare, MedBridge exemplifies the potential for adapting general vision language models to specialized, data-scarce domains. Looking forward, several trends and challenges define the horizon for computer vision research. Lifelong learning from raw, unlabeled data streams is emerging as a key direction, enabling models to autonomously develop object concepts and scene understanding. Modular, adaptable foundation models will facilitate rapid deployment in new domains, especially where data is limited. Efficiency and real-time inference on edge devices are increasingly prioritized, supported by advances such as those in Alter. The need for deep multimodal and spatial reasoning is growing, aiming for true scene understanding across diverse inputs. Finally, transparency, trust, and ethical deployment are receiving heightened emphasis, ensuring that powerful AI vision systems remain responsible and reliable. This briefing was created through a synthesis of AI and human expertise. The summarization process was powered by GPT 4.1 from OpenAI, with text-to-speech synthesis delivered via DeepGram and images generated using OpenAI tools. All synthesized content underwent review by a human expert to ensure accuracy, though minor oversights may exist. For full details and references, listeners are encouraged to consult the episode notes. This collaborative approach combines the strengths of state-of-the-art AI with careful human oversight to provide a trustworthy and informative overview of the latest in computer vision research. To stay ahead with the latest developments in AI and computer vision, listeners are invited to subscribe to the AI Frontiers YouTube channel for regular updates. Joining the AI Frontiers community provides access to ongoing insights, expert analysis, and curated briefings on breakthrough research. Thank you for exploring the future of artificial intelligence and computer vision with us.